thanks for introduction. First I have to say that I thought that my presentation is in German language, but as the system can't translate it, I will try to do it in English. Anyway, I'm really glad that I can give you a presentation on one of the most innovative projects of Austria, the project Wienthalterassen. You get a first impression of the project from the first slide. You see the picture here. It's a quite huge residential building with about 300 flats. And I collected some key facts on this slide. The project has, as I said, about 300 flats, and it has a gross floor area of about 30,000 square meters. Yeah, the project was finished pretty much like 1 year ago, and I can give you some more information on the technical system. You get some impressions here from this slide. We have a system that's yeah, a combination of a geothermal field. How does that work?
You should show by this way.
Ah,
okay, okay.
Okay. Works like. Whatever. It's a combination of a geothermal field and a wastewater recovery system. And both of the systems are like heat extractions for a heat pump, and the heat is then delivered to thermal activated building parts and to the hot water system. The geothermal system can be, there can be heat generated from solar collectors and also an asphalt collector, like there are pipes in a street, and you can collect heat there and put it back into the earth via the geothermal system. I now have an energy flow diagram here, and you can see the amount of energy or heat transported or being delivered by the size of or the width of the arrows shown here. And I can use this figure for energy flow explanation and also for an explanation on how the system works itself. Described by the number 1 on the lower level here, we have our geothermal field. That's actually 2 geothermal fields. We have 64 geothermal probes with each with a length of 142 meters. And the geothermal probes provide heat for heat pumps. We have 3 big heat pumps that lift up temperature for the tap system and also for ventilation systems. But the main delivery system is the tap system for the 300 flats. Then you can see with the blue arrow where heat is being brought back to the geothermal system to have a balance in the ground system. The other system is the geothermal, the wastewater recovery system that provides heat for the hot water system. And the plant was designed like pretty much separated for room heating and hot water heating. And as you can see with the width of the red and the pink arrow, you can see that the heat delivered by the geothermal field for room heating was pretty much as much as the heat needed for the hot water system. How does that wastewater recovery system work? The system collects all the wastewater from toilets, showers, etc. And collects it in one big concrete slot. From this concrete slot, the heat is extracted by a heat pump and temperature lifted up to for the hot water system. On the left side now we have data from the first year monitoring of this hot water system, and we can see in the first 4 months that the waste recovery system did not cover all the heat that was needed for producing hot water, but then we found some failures in the system. So from May to December the hot water was produced almost, or pretty much almost, by the wastewater recovery system, which is combined with a small air heat pump that is situated in the technic room and extracts heat from the boilers and heat pumps, etc. So the next slide shows gives some impressions from the depth probes, the geothermal system. We have shown on the left diagram in the green fields on the x-axis. We have the heat that is distracted or put into the geothermal system. And the green lines are the flow and return flow temperatures of the geothermal field. And we did see that the temperature in the geothermal field dropped pretty quick to about 0 degrees, and in winter or heating season, and then in summer going up to like 20 degrees. And we were thinking that okay, the geothermal field is almost extracted, so to say. But then we discovered that when we switch off loads and letting the geothermal pump still run, the temperature from return flow and return flow dropped like 4 or 5 degrees. So that's how you can discover the real Earth temperature. Because during you extract loads from the system, it's hard to say which temperature the Earth really has. The next slide shows how the tap system works. We have on the left diagram shown the connection between outside temperature and heat delivered to the system. We needed about 400 kilowatts at about minus 10 degrees. That was the maximum power we needed for the system. This was just for a couple of hours. We have on the next slide, we can see how like there's just some peaks. In reality, it's actually lower power that we need. During the cooling period, we needed about 200 kilowatts. And on the right diagram, you see the heating curve, so to say. We have the first half year in the blue heating curve, or the dotted representing the heating curve, and the second half year in the brown dots. And as you can see, the flow temperatures were in the first half year about 31 degrees at minus 9 degrees outside temperature, and in the second year only 28 degrees flow temperature at minus 9. And here we have a detailed analysis on the flow and return flow temperatures and the heating power delivered to the system. And as I said before, never mind about the first couple of days in this 2 weeks that we displayed here. And as you can see, when the outside temperature drops on the lowest level, which was pretty much here, we had this minus 10 or minus 9 degrees outside at that point. Here we had that 400 kilowatts of power delivered to the tap system, but this was just like a couple of hours. I would say if we had just like 350 kilowatts, the system would also have worked pretty much the same. And also you can see the flow and return flow temperatures on the red and blue line shown here. And what we did see is that spacing between flow and return flow was most of the time lower than 2 Kelvin. And just when the outside temperature dropped on its lowest level, then we had like 3 or 4 degrees spacing between flow and return flow temperature. So on the last slides, I have some diagrams on comfort analysis of some of the flats in this project. And this is a flat in the ground level of the whole building. And what you can see is on the upper diagram, we have a gray line, a yellow line, and a red line, I would say, yes. The gray line is concrete core temperature. The yellow line is surface temperature of the concrete ceilings, and the red line is the room temperature that we measured. And you can see like 3 Kelvin spacing between surface temperature and room temperature, saying that there is like that heating was on in this flat, so to say. Pretty much all the time. When we go to the next slide, we have a flat in the 3rd floor. And here you can already see that the spacing between the surface temperatures and the room temperatures is really small, so that most of the time there is just a little bit of heat giving to the flat from the system. And then the last slide. Time is over, flat on the 7th floor. And also here you can see that the spacing between surface temperatures and room temperatures is way not as big as in the ground level floor flat. And saying also that there is not so much heat needed in these rooms. And that's what we actually discover with all the tubs heated buildings. Ground floor flats need more heat, and so it's always a good idea to have floor heating as well as tubs heating on the ground level. That's pretty much my presentation. Thanks.
Thank you. I am not sure if we have some question from Slido or not. I would like to ask you to these conclusions, because you said something what was mentioned here also before, when we were talking if we are using only the ceiling for heating and cooling, or we can use also floor, especially in the basement or in 1st floors for the floor heating. It means it's also your observations, something like that? That
covers our observations. In this project, the floor is not activated, so to say. And the response from people living there is actually good, but surface temperatures on the basement level are a little bit low, and that's what people sometimes complain about.
And the second question, because your paper is entitled Monitoring, what does it mean? You show us something about the temperature profile, about the surface temperature. Is it somebody who is evaluated it regularly and maybe based on results trying to put some other control strategy?
We have all 3 months, we sit together in the whole project team, the planning team, the building team, like the companies that were constructing the building, and us from the monitoring team, and we are trying to optimize the building, how the building is working. So that's what we do.
Okay, and the last question from the public. In the project you mentioned that there are applied also solar panels and some other collectors.
Asphalt collectors.
I was not sure in English. Why you mentioned that they are not using too often? What is the reason? Or
as you could probably see in the energy flow diagram, I said that the width of the colored arrows shows how much energy was transported. It was just a line, so no energy or heat transported by solar collectors and also these asphalt collectors. Why was that? We were not sure how the geothermal field would react on too much heat provided to regenerate the Earth. And so we decided in the first year not to use the asphalt collectors and the solar collectors, so that the cooling for the flats is guaranteed in the first year. So now we discovered that this worked pretty fine, and next year we are going to use the solar collectors and the asphalt collectors as well.
Okay, thank you very much.
Thank you.